Welcome back to another video of the CocoLabs Enterprises. And today is the long-awaited Phase 1 video. Let's go. To start, we needed motors and electrical components. For our electrical, we used FRC legal components wherever we could. FRC stands for First Robotic Competition, and many of the components that they used in the competition was powerful enough for us. However, so much of it was out of stock. So we bought enough parts to get started, but we still needed to order more parts as the build progressed. Next, we needed to build a chassis. We had three options. The first one being we can design it ourselves. The second one is we can use something called T-slots or 80/20s to build it. Our third option was to have someone else design it for us and walk us through the process. Our first option was to design it ourselves. The pros of this is that we can find a lot more detail and know everything that we want that goes onto our chassis. The downside is that it's going to take a long time, and we didn't have any machine shops around us to actually build the chassis. Our second option is to use 80/20s or T-slots. T-slots is an aluminum extrusion that is in already custom sizes, but then if you have a machine shop, you can cut it down to the specific lengths that you need to build your project. Their market is as being versatile, easy to use, and really fast to build. However, the downside is that you may not get as much precision or as much space efficiency as you'd want, and we had no machine shop to actually build it again. Our final option was to let someone else design it for us. The upsides of this is that we get to talk to someone more specialized, and this will allow us to know if we wanted fans, then they'll tell us how much fans and where to put them so that we have structural integrity. The downsides are that if we forget to mention anything in design, then the moment they ship it, then there'll be no do-overs. Another downside that we did not know at the time was shipping time. It took weeks to get here, and that was valuable time we could have spent building the robot. We finally went with letting someone else design it for us. We found someone called Super Droid Robots, and they have specialized kits that you can build or design. We met someone named David, and after a really long email chain, we finished designing, and he told us that it'll take 3 weeks to ship.
3 weeks later. 2 days later.
The chassis that we're actually gonna build got here, and it took 5 years, so yeah. Now we're gonna unbox it.
That's not quite accurate.
Okay, Gaywell, anything you would add?
It's actually taken 3 weeks. Not exactly.
Oh, okay.
It's okay. It seemed like 5 years. Though.
Akil, what about you?
Yeah.
Are you guys excited?
Yeah.
Yeah.
Yes.
Packing me
No. We have to clean that up. There were way too many packages.
Guys!
Chris, no more packages.
Yeah, please.
The chassis!
Alright, Chris.
I guess we'll worry about it later.
Nice.
No, Chris.
Okay, now
Oh, wow.
It smells like a bike shop. Of course, it's bike. No, it's not bike.
Number one!
Imagine these on bike.
Let's go!
How big it is.
Wait. So I think what's supposed to happen is you can just like go like that, and then that's how you spin the wheels.
Sure.
So. After unboxing, we went straight to work. However, there was a lot of problems that we needed to solve.
We put 2 of them in, and now we're struggling with a key that's in that. That's really bad.
Keys suck, okay? Like everyone should just switch to hex
So,
strap.
Akil, you wanted to show me what you did today? Here.
Yeah. So okay. So we put these things on, and then we put motors in. We put sprockets, and then chains, and then bearings.
You feel good about today's work? Yeah.
That means no.
Yeah. Basically, yeah. So that's bent because it screws, and then we need to bang that against that, and then that's flat. Okay.
Oh, wow! Ideas do work sometimes.
It's flat. All right.
Alright, good job, Akil.
Another problem that we had was that once the wheels were attached to the robot, they kept rubbing against the side of the chassis. This was a huge issue, as then we have unnecessary friction that we don't want to deal with. So as a solution, we attached metal bolts and extended it such that the wheels are a little bit further out from the chassis, but then they bent. So now we need to cut them off and replace them. So, more bad news. These wheels. So, let's see here. So, this is looking at the trash machine forward, where you can see the tires that all have the wheels facing forward, and it's all great, except this is when it's upside down. So, technically, if you lift this right side up, if you look at it now, the arrow's in the front, over there, facing forward, but then the wheels are facing backwards. So we need to fix that. After we finished building, I wanted to see how much weight we can actually put on this. Online it said around 180 pounds, but I did not believe that, so I needed to see for myself. Yo! Oh, we're driving a keel on this. He's gonna sit on right here, and I'm gonna just drive it. It's gonna be like Mario Kart 2.0. So this is the liability form Akil needs to sign. So that if anything goes wrong riding this, it's not our problem.
Alright, I, Akil,
Okay.
do not blame CocoLabs or any of its employees. If self-harm comes to me, I'm responsible for my actions. And I'm not forced or threatened to do anything I do not want to do.
Alright, right, signature. That's not a signature, but it works. Okay, here. We got photo evidence here. Photo evidence that Akil himself has signed this liability form. And here we go. Oh, this is going to mark the latter phase of phase 1. So today we are doing a test of whether or not this can drive on asphalt. And then we're gonna run the same 3 tests on the grass as that is our desired destination. So, test 1, pull forward. Whenever you're ready, Akil. Oh, wait, that's actually really slow. Anticlimactic. This is point 2.
That's it?
Yeah, I see anticlimactic. Okay. Oh, click the button, Akil, the button. Okay, that's the fastest we're gonna be going today.
Let's do one, okay?
Now we're gonna try to turn in place.
Stand in place.
There you
Do
go.
it slowly. Okay.
How do we do the math for that? It's just like all.
Oh, it's gonna be all forward. So the issue with spinning in place is there's 4 points of contact, and it may be the same thing as just putting the chassis on the floor and trying to just turn it. So it may not go well.
Alright, 3. This is at 0.5.
Okay, 0.5.
3, 2, 1.
Wait, 0.5? Oh no, 0.05. Yeah, so the issue is,
Oh, you got a wheel that's not turning.
yeah, because there's no torque on it. They're trying to turn. So test number 3 is we're putting a keel on this and then running forward. So
Go!
oh no, to the water! Go! How's it going? Just cruising.
It does not feel stable. The thing's like moving. Dude. The 80-20s are moving.
Okay.
Stop it.
Okay. Oh my god! Okay, we're stopping.
Alright, the trick is lean forward.
My turn. Oh my! Ah! No! So after I went at full speed, the chain broke. And then after Howard went at full speed, we lost an entire hex shaft. And this is the shaft that connects straight to the motor.
Guys, block it! Block this rocket!
No more joyrides after that one. Our robot drove. It was insane. However, it still can't turn. So, over the next couple days, we tried to fix that with some testing.
Alright, what's the test?
So, the test, we're going to be trying the turning test again, except we're just going to put more force into it.
3, 2, 1, crash.
Oh, it just takes a lot of power.
Wait, do it again.
So,
3, 2, 1.
uh-oh.
Here, try again. I'm gonna.
Stop.
Alright, so we're doing a skid test where we're gonna try to make these two wheels skid and hope that it turns.
And how are you doing it?
Well, we put cardboard here so that it slips, and then we're gonna only power the back wheels.
Alright, let's give it a try.
Okay. One.
Okay.
Our final solution to the turning problem, though we didn't want to do it, was to increase the gear ratio so that we get more torque and we can put more force into turning. And this actually worked. After the robot could actually drive, we focused on getting something to drive it using a remote controller. In FRC competitions, they normally use a remote controller that's connected to the RoboRio over Wi-Fi. However, that's not an option for us as we're driving outside. So our solution was to use an RC controller. The issue with this is that the RC controllers cannot connect directly to the RoboRio. So our solution to that was just going to go from the RC controller to the RC receiver, and then from the receiver we're going to send the signals to an Arduino, which then sends the signals through I2C protocol to the RoboRio. Yeah, it should be running. It's not, it should be running. Oh, communications! It's green! Why is robot code not green? Oh, why is it going backwards?
What's wrong?
I did my math wrong.
Are they turning in the wrong direction?
Yeah. Now it should be working, so moment of truth.
Guys, to clarify, this is completely first try.
Yeah, exactly.
We wrote all this code in a single minute, to clarify. Yeah. So, that's forward. It's going back.
Okay, stand by.
So we're going slightly forward,
Nice.
and I'm gonna turn left now. You better.
Oh my gosh.
It's turning.
Slightly forward.
Oh yeah, let's try it.
We don't have to pick it up.
Okay. Thank you so much to Sohini, Duijin, and Pranav for helping us in this phase, and see you guys in the next video.